Thank you very much. I'm Steve Barnett of Barnett Technical Services. We've worked with the Golden Gate Polymer Forum for many years, and we're very pleased to act as a sponsor for this course. I'd like to tell you a bit about some of the work we do in relation to the polymeric sciences. We have about 30 years of experience in the field. We're based in Northern California. Our expertise falls into two broad categories. First, we work quite a bit with a range of spectroscopic methods of analysis. We work in FTIR, Raman, and near-IR at the beginning and have brought down to other methods. We also do quite a bit of work and have quite a bit of expertise in microscopy and in micromanipulation. We do consulting and training, and also quite a bit of our work is in acting as a sales rep or distributor for some of the vendor companies that we work with. Since we also do the consulting and the training, in addition to acting as a sales distributor, we also handle quite a bit of the support for the companies that we work with. I'd like to spend a few minutes to tell you about a few technologies that are related to the characterization of polymeric materials. First is Ostec Instruments. They're a European company with a wide range of analytical instrumentation. They have decades of experience in instrument design and manufacturing. They manufacture FTIR spectrometers and FTIR microscopes, as well as Raman microscopes. One interesting application is the use of fast Raman imaging, where they implement a galvo mirror scanning system to rapidly move the Raman laser, across a surface. So this can be used in the current example to provide images of dispersions of polystyrene, PET, and polyethylene. On the right side, you can see the different Raman spectra for these three materials, which can easily be used for identifying the three different polymers. Looking at a white light image of dispersed beads and dispersed grains of these three polymers, you can see that the Raman spectra are very different, even though the white light image looks identical for all three. And to do a fast Raman image here, you can see that the three colors are used to identify the identity of which polymer each grain is. This allows the Raman image to be generated very quickly and very precisely, which is valuable for high throughput screening as well as to perform high resolution Raman imaging measurements. The second technology I'd like to discuss is a benchtop super resolution microscope called the Nanoro M, which is manufactured by LIG Nanowise, a UK-based company. They have a white light microscope with a specialized objective that allows you to obtain ultra high resolution images through their white light microscope. Typical resolutions are about 100 nanometers per pixel, far over and far better what you would normally expect from a white light microscope. You can generate full color images with their system. So in essence, what you have is the capability to generate images similar to lower range SEM images in a white light microscope. So sample prep is quicker, and the flexibility of what types of samples you can measure are much more flexible as well. Finally, I'd like to speak about the MicroSupport Access Pro micromanipulator. For those of you who have been to GGPF events before with us, you've seen this. This is a microscope with an XYZ stage and motorized arms that can all move in X, Y, and Z controlled by stepper motors. Motion of the stage and the arms is through software control. You can add a wide range of microsampling tools, including probes, knives, scrapers, and microtweezers, to name a few. This product is valuable for failure analysis and particle isolation, as well as for doing precise microsampling. To give you one example of a customer application, a customer came to us and asked us to separate one layer from a multi-layer coating. In this case, they wanted a piece of the blue layer separated from the substrate coatings so that they could run FTIR measurements on it. For this work, we used an accessory called Milling Pro, which consists of a horizontal blade, in this case it's about 100 microns across, made of tungsten carbide, which can be used to scrape off the surfaces. However, we can also introduce a hypersonic vibration into that tool, which provides for even smoother scraping of the surfaces. In this case, that was extremely valuable because the uh, surface polymer is not a very crystalline polymer. It's fairly amorphous, and so typically getting a smooth shaving can be difficult. In this case, you can actually see that we're able to shave off that upper surface. And I'm going to step through this video since it's about 6 minutes long. Once it's shaved off the surface, we can also use a second probe on the right side, which is just a tungsten probe, to press that grain between the two probes so that we can transfer it to the FTIR substrate. You can actually see here, you can see that grain pressed between the two probes. Now we've reached the substrate. The substrate was in essence a piece of Scotch tape. They wanted to locate this grain at the edge of the Scotch tape for FTIR transmission measurements. You can see the grain is located right here. This entire thing took about 7 or 8 minutes, whereas typically it was difficult for them to get any kind of separation of those. Finally, to give you an example of micro tweezers, here we have 19 micron diameter fibers that can be used to isolate single fibers from a mixed fiber matrix. We approach the micro tweezers to the fiber, squeeze down on the fiber. If you're doing this by hand, you'll move the micro tweezers to the right, in this case. However, if you also move the substrate to the left, or the stage to the left, you can keep the fiber and the micro tweezers in the field of view that you're observing so that you're always seeing if the micro tweezers are holding onto the fiber, which in this case, they clearly are. Thank you very much. Our contact details are here. We'd be happy to answer any questions that you send to us, and we'd love to speak more with you and have a great course. Thank you very much.